Race car drivers operate in one of the most physically demanding and high-risk environments. Exposure to extreme temperatures, both inside the cockpit and from the heat generated by the engine and the racing environment, makes heat management a critical concern. High-tech racing suits are designed to address these challenges by using advanced materials and technologies to regulate temperature and improve comfort. Motorsport fans are getting their first taste of racing this year, with the opening Grand Prix of the 2025 Formula One F1 season in Melbourne. But it's not just the cars people should be watching. In a sport where milliseconds determine champions and conditions push the human body to its limits, drivers' racing suits have evolved from a simple fire protection tool to a sophisticated performance tool. In fact, today's F1 suits represent something of a technological revolution that could determine who stands on the podium. F1 drivers compete at nearly 300 km per hour while enduring cockpit temperatures of up to 50 degrees Celsius. In case of an accident, they are required to wear multi-layer fireproof clothing, including long underwear, a balaclava, gloves, and a helmet. But this can severely restrict the body's natural cooling mechanisms. Racing car drivers often experience extreme heat conditions inside the cockpit of their vehicles. Temperatures can soar to over 120 degrees Fahrenheit 49 degrees Celsius during intense races, especially in endurance events like the 24 Hours of Le Mans. These high temperatures, combined with the physical demands of driving at high speeds, place considerable stress on the driver's body. The risk of heat stroke, dehydration, and fatigue are serious concerns, which is why race car drivers rely on cutting-edge technology to keep their bodies cool and maintain peak performance. High-tech racing suits are a key part of this strategy, employing specialized materials and integrated cooling systems to manage body temperature. Developers of driving suits therefore have a challenging job. They must design garments that provide maximum fire protection while also allowing drivers to maintain peak cognitive and physical performance for roughly 2 hours in extreme heat. Fire protection remains the primary function of racing suits. Because of this, flame-resistant synthetic materials such as Nomex, oxidized polyacrylonitrile, and polybenzimidazole are used for the suit. Wool is also prevalent in the inner layers because of its flame-resistant characteristics. But racing suits are also now designed to improve driver comfort and movement. For example, the racing suits of motorsport company Alpinestars, which supplies the McLaren F1 team, feature pre-curved sleeves and legs that match the natural driving position. This reduces the energy drivers expend fighting against their clothing. Alpinestars suits also have minimal seams around the elbow joints. This increases flexibility and eliminates pressure points during the continuous small steering adjustments drivers make throughout a race. The suits also have elasticated inserts and multiple panels around the elbow, which reduces material bunching at this crucial joint. Sportswear company Puma, which supplies the Ferrari and Aston Martin F1 teams with driving suits, adopt similar features in their driving suits. But this attention to joint mobility extends beyond elbows. F1 suits are flexible and loose-fitting around the arms. They also incorporate elasticated panels in the lower back region and seamless shoulder epaulettes. This means the suits move naturally with the driver and minimize resistance. Historically, racing suits were simple protective garments made from cotton or wool. While these materials offered some protection, they were insufficient when it came to heat management. As motorsport technology advanced and race car cockpits became more tightly enclosed, the need for effective heat regulation became more pressing. Drivers began to experience heat-related issues, which led to a demand for suits that could not only provide protection from fire hazards but also help keep drivers cool and comfortable under extreme conditions. In the 1980s, a shift occurred as racing suits began incorporating synthetic fabrics such as Nomex, which offered fire-resistant properties. However, it wasn't until the 2000s that manufacturers began developing more specialized materials and designs to address heat stress directly. The integration of new fabrics, ventilation techniques, and active cooling systems marked the beginning of modern high-tech racing suits. Technology behind high-tech racing suits: fabric composition and insulation. Modern racing suits are made from multiple layers of specialized fabrics designed to balance heat protection with comfort. The primary material used is Nomex, a heat-resistant synthetic fiber that can withstand high temperatures without igniting. Nomex suits are often combined with other materials like Kevlar for added durability and fire resistance. However, while these materials offer excellent fire protection, they can also trap heat. This is why modern racing suits are designed to be lightweight and breathable, with a focus on moisture-wicking properties. Many racing suits now feature advanced fabrics like Pyrovitex, which provide thermal protection while being breathable and lightweight. Aerodynamics and ventilation. Ventilation is another crucial factor in keeping drivers cool. High-tech racing suits often have strategically placed vents that allow air to circulate through the suit, helping to cool the driver's body. These vents are typically located in areas with high heat buildup, such as the chest, back, and underarms. The goal is to create airflow that helps to dissipate heat and keep the body temperature in check. Integrated cooling systems. In addition to fabric design, some high-tech racing suits feature integrated cooling systems. These systems can involve a network of small tubes that run along the suit's interior. Coolant, typically chilled water or air, circulates through these tubes, drawing heat away from the driver's body and helping to maintain a comfortable temperature. The most common system is a liquid cooling system, which uses a small, portable pump to circulate cool water through the suit. Some high-end racing suits also include built-in fans or air circulation systems. These suits draw in cool air from outside the cockpit, using fans to direct airflow through the suit. While these systems are more common in endurance racing, where drivers spend long hours in the car, they are becoming more prevalent in other forms of motorsport. Hydration systems. Dehydration is a significant concern during long races, as it exacerbates the effects of heat stress. Many modern racing suits are equipped with hydration systems to help combat dehydration. These systems typically consist of a small, integrated tube that connects to a water reservoir. The driver can drink while racing without needing to remove their gloves or divert attention from the race. Smart suits with sensors. The next frontier in high-tech racing suits is the integration of smart technology. Some companies are developing racing suits that incorporate sensors to monitor the driver's temperature, heart rate, and hydration levels in real time. This data is transmitted to the team's engineers, who can make adjustments to ensure the driver is not overheating or suffering from dehydration. This technology is still in development but shows promise for enhancing driver safety and performance. Impact on driver performance. The primary goal of high-tech racing suits is to keep drivers cool, and this has a direct impact on their performance. Maintaining an optimal body temperature is critical for several reasons. Physical endurance and focus. Heat stress can lead to physical fatigue, which in turn affects a driver's ability to focus and perform. Racing requires intense concentration, quick reflexes, and the ability to withstand high G-forces. When a driver's body temperature rises, fatigue sets in more quickly and mental sharpness diminishes. High-tech suits help prevent overheating, ensuring that drivers can maintain focus for the duration of the race. Reduced risk of heat stroke and dehydration in extreme temperatures. Drivers are at risk of heat stroke and dehydration, both of which can have serious health consequences. By keeping drivers cool, high-tech racing suits help reduce the risk of these dangerous conditions. This is particularly important in endurance races, where drivers are in the cockpit for extended periods. A cooling suit can lower body temperature by as much as 5 degrees Celsius (9 degrees Fahrenheit), which can make the difference between completing a race and suffering from heat-related illness. Comfort and confidence. Race car drivers often experience high levels of stress during a race, and discomfort caused by overheating can add to this stress. High-tech suits that regulate body temperature contribute to overall comfort, which in turn boosts a driver's confidence and mental state. Knowing that their body is being protected from heat stress allows drivers to focus on their performance rather than their physical discomfort. Developers of driving suits therefore have a challenging job. They must design garments that provide maximum fire protection while also allowing drivers to maintain peak cognitive and physical performance for roughly 2 hours in extreme heat. Fire protection remains the primary function of racing suits. Because of this, flame-resistant synthetic materials such as Nomex, oxidized polyacrylonitrile and polybenzimidazole are used for the suit. Wool is also prevalent in the inner layers because of its flame-resistant characteristics. But racing suits are also now designed to improve driver comfort and movement. For example, the racing suits of motorsport company Alpine Stars, which supplies the McLaren F1 team, feature pre-curved sleeves and legs that match the natural driving position. This reduces the energy drivers expend fighting against their clothing. Alpinestars suits also have minimal seams around the elbow joints. This increases flexibility and eliminates pressure points during the continuous small steering adjustments drivers make throughout a race. The suits also have elasticated inserts and multiple panels around the elbow, which reduces material bunching at this crucial joint. Sportswear company Puma, which supplies the Ferrari and Aston Martin F1 teams with driving suits, adopt similar features in their driving suits. But this attention to joint mobility extends beyond elbows. F1 suits are flexible and loose-fitting around the arms. They also incorporate elasticated panels in the lower back region and seamless shoulder epaulettes. This means the suits move naturally with the driver and minimize resistance. Adjustable features such as elasticated waists and belts allow drivers to personalize their suits. They can also request specific modifications, such as where ventilation openings are placed, based on their individual comfort needs. The result is a racing suit that functions as a second skin, tailored precisely to each driver's body and movements. Racing suit manufacturers have also developed advanced approaches to keep drivers cool as well as safe. Adjustable features such as elasticated waists and belts allow drivers to personalize their suits. They can also request specific modifications, such as where ventilation openings are placed, based on their individual comfort needs. The result is a racing suit that functions as a second skin, tailored precisely to each driver's body and movements. Research has demonstrated that advanced fabrics with improved air permeability, how air passes through the fabric, and breathability, how moisture and heat passes through the fabric, as well as reduced thickness, could reduce core temperature rise by 40% compared to thicker and tighter types of materials. Fabric manufacturers have engineered breathable fabrics for the suit and inner layers. Product developers also strategically place ventilation zones and internal cooling systems with technology that draws moisture away from the skin in the suits to help drivers manage their core temperature. These thermal management features are carefully tailored to different body regions. For example, knowing that elbows experience a 6 to 7 degrees Celsius temperature increase during racing, suit designers make the suit thinner in this region to improve airflow and use materials capable of adjusting their thermal properties to temperature. The impact of these design innovations goes beyond basic comfort. They translate directly to competitive advantage. When body heat is better managed, drivers can think more clearly and have better reaction times. The road ahead. The development of racing suits continues to accelerate, with several emerging technologies promising even better performance and safety. Reflective elements are showing particular promise for thermal protection by reducing the rate of skin temperature increase compared to conventional racing suits. Wearable technology built into the fabrics of suits can also monitor drivers' physiological changes and help predict performance changes and enhance safety during racing. The emerging popularity of electric racing series such as Formula E is also changing the environmental challenges drivers face. Electric cars generate far less heat and noise than traditional race cars. This shift may prompt a re-evaluation of suit requirements. It may potentially allow for designs that prioritize driver comfort and performance over heat management, while maintaining their fire safety properties. The next time you watch an F1 race, look beyond the fancy aerodynamics and engine performance. Observe who emerges from their cockpit looking relatively fresh after 2 long hours of driving. The competitive advantage might not be in the car alone. It might be woven into the fabric protecting the driver inside the car.